Hi, welcome back to Chapter 6, Section 6. We're dealing with solving radical equations. To begin with, we need to know what a radical equation actually is. First off, a radical equation is any equation with an actual radical in it. Any equation with a radical. All right, so basically what that means is you've got an equation like y equals the square root of x. That is a radical equation. You also have to remember that radical equations can be written with rational exponents. So this could be x to the 1/2. So the definition, an equation with a radical, that also should be an equation with a fraction exponent. And it comes in 3 steps. The first step is that you need to isolate the variables, or isolate the radical, on one side of the equation, if necessary. So that means if you have the square root of x, and there's a +2 outside of it, that's equal to y, the first thing you need to do is isolate the radical by subtracting 2 to get the radical all by itself. That's true for rational exponents. If you had x to the 1/2 +2, you need to isolate the radical on one side of the equation by subtracting 2. That's how this is set up. The next step is to raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. So that means from right here, you would raise this square root to the second power. So your new equation would be x equals the y minus 2 squared. That's how that's set up. For rational exponents like this one right here, it's a little bit different. You still square it, but sometimes it's not going to be a nice one. So if you have x to the 1/2, you do still square it. You basically raise it to the 2/1 power. So hopefully you're recognizing that a 1/2 power to a 2/1 power cancels out to equal just x. So this is called the reciprocal. The reciprocal. So if you had x to the 2/3, you would raise it to the power of the reciprocal, 3/2. If you had x to the 1/4, you would raise it to the, we'll call this 14/4. You would raise it to the power of 4/14. The 4's cancel, the 14's cancel, you're left alone with x. So you are raising to the power. Then step 3 is to solve the polynomial equation using techniques we've learned from previous chapters. So you may have to FOIL, you may have to multiply, you may have to add or subtract. There's a lot of different things you may need to do. And we'll see lots of examples of that today. So the first one here, write the original equation, square each side to eliminate the radical. Remember, step 1 is to isolate the radical. This has not been isolated, or this is now isolated. So you raise it to this, you basically square both sides, and you get x plus 6 equals 3 squared, which is 9. Now it says to simplify by subtracting 6, and you get x equals 3. So the solution is 3. Check out this checkpoint question on your note-taking guides. First question, is the radical isolated? And you should see that there's a +1 here. Therefore, it's not isolated. Subtract 1. And now you get that the cube root of x minus 5 equals -2. So, we've isolated it. Raise it to the power. This is a cube root. You need to cube the cube root. Those then cancel. When they cancel out, x minus 5 equals -8. Last step, solve for the variable, add 5 to both sides. You now have a solution of x equals negative 3. So those are the steps to solving radical equations. You really should check to see if x minus 3 is a solution. So you're going to grab your calculator, you're going to stow a little arrow, type negative 3 and hit enter. And basically what the calculator will do for you is now plug negative 3 into the equation to see if it works. You'll do cube root of x minus 5 in parentheses. You'll do plus 1, and it should equal negative 1. And when you do this, for this one, I can guarantee that it works. But you should check your answers if you want to make sure you got them right. All right, let's take a look at some of the couple of the guided practices, please. Well, we'll do number 1 and 3. So number 1 looks like the cube root of x minus 9 equals negative 1. Now, if you want to try this on your own, just pause the video, work it out on your own, and see if you did all the steps correctly. So, first step, write out the original equation. Second step, isolate the radical. Isolate the radical. Minus 9, we got to get rid of that. So plus 9. Plus 9. The cube root of x equals 8. All right, how do you now get rid of a cube root? You raise it to the same power. So x equals 8 to the third power. 8 to the third power ends up equaling 512. Guided practice number 1. Guided practice number 2. Actually, we'll do number 3. Number 3 looks like 2 cube root x minus 3 equals 4. So, is the radical all by itself? You might say yeah, because there's no adding or subtracting to it, but you are multiplying by 2. So let's get rid of that 2 first. Undo multiplication by divide. The cube root of x minus 3 equals 2. 4 divided by 2 is 2. Ask yourself, how do you get rid of a cube root? You raise it to the third power. X minus 3 equals 8. Add 3. X equals 11. And that's it. That's how this is set up. If you want to try guided practice number 2 on your own, feel free. We'll see how it goes. So let's move on. Here's solving an equation with a rational exponent. We've already talked about how to do this. You look at the reciprocal of the power. So raise each side to the reciprocal power. So we take this, we raise it to the reciprocal power, 3 halves. 3 halves. Those now powers cancel out over here. And when you raise it to the third 3 halves power like that, type it into your calculator, you'll get that 16 to the 3 halves is actually 64. So now there's a bunch of different things on what you can do here. We did some of them together, all together in one, but we subtract 4. We divide by 3. And you get that x equals 20. And as always, you really should check to see if that is the correct solution. So for this one, I can tell you it is. So example 3, x minus 2 equals the square root of x plus 10. This is example 3 from your note-taking guide. Step number 1 is to isolate the radical. Is there anything we can do to this radical now? This bar goes all the way over the 10 and the x, so we can't do anything. The only thing we can do is to get rid of it. So we square. So you end up with x plus 10 here, and you end up with x minus 2 times x minus 2. That's what it means to be squared. Now, if we were to simplify this, or FOIL this, x times x is x squared. X times minus 2 minus 2x, another minus 2x, and a plus 4. That's equal to x plus 10. So let's write in standard form first. So we're going to have x squared minus 4x plus 4 equals x plus 10. All right. The next step here says we have to, it looks like it's equal to 0, which means we have to subtract x from both sides. I'm sorry, subtract x and subtract 10. So minusing 10 there, minusing x. And what we get is we get an x squared minus 4x minus 1x is minus 5x. 4 minus 10 is minus 6. And here it says to factor. We can actually do whatever ways we want to solve. So like I said, you can use whatever methods you want to solve. You can factor, you can graph this. Like if you were to graph this, I think it would look something like this. You'd have this graph starting here, go down to some minimum value, then come back up through like that. And my graph isn't that great, but on the calculator you'll see that it crosses at -1 and it crosses at +6. So those are your solutions, -1, +6. So you can graph it, you can factor it and say that it's x minus 6, x plus 1. Okay. You can factor it like that, or you can even quadratic formula. I mean, these are all the things that we've been working on. The quadratic formula, remember, is x equals opposite b plus or minus square root b squared minus 4ac all over 2a. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. That's how it's done, folks. All right, so we'll take some time, look those over. We're going to start the guided practice. Guided practice 5 through 10. You are now, it's just like before, you're solving for a variable. So let's set it up. Let's look at number 5. Number 5 is 3x to the 3 halves equals 375. So we have to isolate the term. Divide by 3. When we divide by 3, we are now left with only the variable and the rational exponent on one side. Now, there are no radicals, so we don't, just cube. We have to remember to the reciprocal power, 2/3 power. That means the 2's cancel, the 3's cancel, and x equals, sorry, that should be a 2/3 power. So that should end up being 25. Your solution is 25. That's how that's set up. All right, so that was number 5. Let's go ahead and skip right to number 10, one of the more difficult ones. This is number 10 from your guided practice. It's x plus 2 raised to the 2/3 power plus 3, and it's equal to 7. So we have to isolate the rational exponent. We have to isolate this thing by itself. So we need to easily just get rid of the plus 3 by minusing. It's 4. We raise this to the, remember, reciprocal power, 3 halves. And what you end up with is x plus 2 equals 4 to the 3 halves. So let's see, it should be 8. and we subtract 2, and you get that x is 6. Now that is one of the possible answers. What you need to recognize is sometimes, see how this is a 1/2 power? When you square root something, it's a plus or minus. So as soon as we did this piece right here, we also came up with x plus 2 equals -8. So when we subtract 2, x plus 2 is -10. So there are two possible solutions. You then check to see if any of them are extraneous. Plug them into your calculator, store them, stow them in for x, and you should be good to go. All right, this one's going to be a little bit trickier. It's going to involve squaring the expression twice. Now, you will not have to worry about this one at all, unless you want to score some extra credit on your 5-question mastery check and then on the test. So, to begin out, always write out the original equation. It says here to square each side. Now, squaring each side is a little bit more complicated than it has been. This side here on the right is the square and the square root just disappear. 10 minus 3x. Over here, though, it's two separate terms. So when you have two separate terms that you square, it actually ends up being, I'll erase this later, it's the square root of x plus 6 plus 2 times the square root of x plus 6 plus 2. So when you do this, now you have to FOIL. So you do the first. You take this piece, multiply by that piece, like you're squaring it, and it ends up being x plus 6. You now take the x plus 6 and times it by 2, and you really can't combine a lot of the stuff together. You just end up rewriting it. All right. Then, of course, the 2 times square root x plus 6, you're just combining it back together again. So it's 2x plus 6. And then the L for last is 2 times 2. So again, we took this, multiplied it by this, and we did the same thing by 2. And then we went ahead and used the other 2, went to there, and went to there. So we multiplied something we did 4 things of multiplication. Now it's a matter of combining like terms. You have 2 square root x plus 6 and 2 square root x plus 6. These are like terms. It can turn into 4 square root x plus 6. Here, you have a 6 plus 6 with a plus 4. That gives you a plus 10. And you have just the x here, so you've got x plus 4. So, squaring each side gives us x minus 4 square root x plus 6 plus 10. All right. So expand left side and simplify right side. All right. What that means is we need to basically isolate the radical expression. So we're going to use this. We're going to do it in 2 steps. We're going to subtract 10 from both sides, which cancels out. So now you've got x minus 4 square root x plus 6. Over here, you've now got a minus 3x. Some minus sign there. Now we're going to subtract x from both sides. So now negative 4 square root x plus 6, negative 3 with a negative 1, negative 4x. We now are still isolating the radical expression by dividing by 4. So divide here by negative 4, divide here by negative 4. Those cancel. You get the square root of x plus 6 equals x. So, square each side. This is why I said this is extra credit. You're going to have to actually do it twice. If you square each side again, now you get x plus 6 by itself, and you get x squared. We simplify by minusing x, minusing 6. So you all end up here. All this here cancels out. You get 0 equals x squared minus x minus 6. So all that work, and we're still not done. Now you either have to factor, you have to graph to solve, you have to use synthetic division, you could even use the quadratic formula. Right? But all in all, when you factor this, you should end up that x is equal to 6 or x is equal to negative 1. So, however you want to solve from here down to here, you can do that. Factoring, of course, is where you do this. X, let's see, this would be minus 3 and x plus 2. Oh, I'm sorry. Those answers are, I was going to say, those don't look quite right. This is not right. All right. Sorry, I was looking at the wrong thing. When we look at this, this is when we actually do the factoring, we're actually going to now say what makes this equal to 0? X minus 3 equal to 0, x plus 2 equal to 0. So you get a 3 or a negative 2. And if you check those then, because you're going to check for extraneous solutions, you'll see that 3 actually does not work. When you store it into a variable, in for x, and then you use your calculator, it won't work. So let's go ahead and get started on practice problems, or I'm sorry, checkpoints. These are from your note-taking guides as well. Here, pause this. Why don't you actually work on these a little bit on your own and see if you get the first few steps. So pause the video, work on it, and see what we can do. I'm going to continue talking though, so it's not a super long video. Here, add 21 to both sides. Cancels out here. You have a negative 2 x to the 4/3 equals, let's see here, adding there, be negative. It's going to be negative 32. Negative 32. Divide by negative 2. And now you get that x to the 4/3 is equal to 16. So, while we're doing this, this is now isolated, has isolated the radical or rational exponent. You go ahead and raise this to a power. Look back at the beginning of the video and you'll see again that it's to the reciprocal power, to the 3/4 power. And when you type that into your calculator to see what it ends up being, you're going to end up with 8. All right. Pause again, try this one out. I'm going to continue. Square both sides. This is a little bit like example number 4 where you have to do some factoring here, or some foiling. That's x plus 2 times x plus 2 equals 2x plus 7. So x times x is x squared. X times 2 plus 2x. Another plus 2x gives you a 4x. So I end up with this. We're isolating, so minus 2x from both sides, minus 7. These cancel, this cancels, becomes 0. You get x squared minus 2x minus 3. And you can, again, you can graph. You can factor. You can quadratic formula. You can synthetically divide. You can do a lot of stuff. All right, let's take a look. Let's do this by graphing. If you type it into the calculator and you go ahead and graph it, you're going to see a graph that looks, let's see here. All right, when you graph this in your calculator, you'll see that it actually crosses through positive 3 through -1, and you'll probably end up with just a parabola. Maybe it looks like this, something like this. Um, all I know is they go through these points, and these points are your solutions. So however you go about this, you should get that x equals -1 or 3. Those are your solutions, -1 or 3. And if you check them, one of these will not work. Okay. Now, when looking at this, as usual, if you were following along and had a question and thought maybe I made a mistake in class, you may have been able to speak up. But in here, you're going to notice that there actually is a mistake on this problem. 4 minus 2 is not -2, it is +2. All right, and that's going to change quite a bit of what we're looking at here. Basically, what it changes is the fact that it goes through these 2 points. So please note these corrections I'm making in red. The graph looks like that. Therefore, it's +1 or -3 as our answers. All right, and this is the true solution. That doesn't work. So again, sorry for the mistake there. Right here, -4 minus 2 is +2, not -2. And that changes how the graph is formed. So that is not the correct graph. Just the red one. These are the solutions. All right, let's do, this is the extra credit one. Okay, this is the extra credit one. I'm going to try to go through it quickly. Pause the video and rewatch it if you need to. You're going to square both sides. And when you square both sides, you're going to end up with x plus 5 on this side. And over here, you're going to have a 1. You're going to have a 3x plus 4. You're going to have a minus 2 square root 3x plus 4. Right? And you're going to combine some stuff here. You're going to, let's see, subtract 3x, subtract 4, and subtract 1. So subtract 3x, subtract 4, and subtract 1. 5 minus 4 minus 1 actually cancels out. A 1 minus 3, you end up with -2. Square root 3x plus 4 equals -2x. You're going to divide by -2. You're going to square both sides. You're going to add 3x and minus 3x and minus 4. Let's not make sure I don't make a mistake this time. And you get that 0 equals x squared minus 3x minus 4. Factoring, graphing, quadratic formula, synthetic division, however you do it, you're going to get that you're going to get solutions of 4 or -1. All right, and what you'll find out is that this one is the true solution. All right, I think we're almost done. Okay, let's do look at 11 and 12. We're not going to do 14 or we'll look at 13. Look at 13. 13, a problem like 13 is actually on your test. So let's do 13 first. The square root of 2x plus 5 equals square root of x plus 7. So we square both sides. Square both sides. And now it's a simple algebra equation. Minus x minus 5. This cancels. This becomes 2. This cancels. This becomes 1x. So your answer, x equals 2. Let's take a look up here. Let's do number 11 from your guided practice. X minus 1/2 equals the square root of 1/4 x. So the 1/4, this is a 1/4. So let us go ahead. Oh, this is an equal to sign. Square both sides. The radical is isolated, so we can square. So over here it becomes 1/4 x. Over here it's x minus 1/2 times x minus 1/2. So when we multiply this out, it becomes x squared minus x plus 1/4 equals 1/4 x. Let's subtract this minus 1/4 minus 1/4. You now end up with x squared minus 5/4 x. You could type that into your calculator if you needed to, plus 1/4. Now, many of you probably will not like this problem in this form, so let's get rid of the fractions. Look at these denominators. What would you multiply 1/4 by to get rid of it and make it 1? Multiply by 4, and our equation in standard form looks like this. From here, I would go ahead and try to factor it, graph it, synthetic division. However you want to do it, you'll end up with possible answers. All right, if you try to graph this one now, you're going to see a graph that looks like it goes, it's going to come through here, somewhere like that, and then come right back through 1. Right? You're going to have to use synthetic division to check to see which one this is or which one this is. You could use the quadratic formula. What you're going to come up with, though, is that the answers are either 1/4 or 1. And for number 11, your answer will be that 1 is the correct solution. So that should help you get through all your practice problems. Should get you through and get the section 6 practice problems. You should be good to go then, and good luck.